Hey, hi. What we are going to study today is neural networks. Um, we'll set the timer, we'll start the timer, and we'll try to close it by the time of 30 minutes today. We also have 30 minutes. Okay. So, uh, so we looked at the plan yesterday for generative AI or NLP to start off. The plan goes like this. Yeah, the plan goes like this. We were looking at basics of neural networking, text processing, word embedding, deep learning, NLP fundamentals, dive into NLP concepts, encoder decoder architecture, attention mechanism, transfer learning, LLM introduction, functional models, prompt engineering, RAG, fine tuning LLM models with different techniques, building LLM from scratch, hands-on projects. So this is our action plan. I should store this somewhere properly. Long back we stopped updating this particular document. The document is actually nice. Today maybe we may use some part of this document, but copy and then here paste. There's no paste special, is it? Man, we'll just take a screenshot of it quickly. Nice. So we go here, take a screenshot. So this will be our plan of action. Okay. We'll refer to it whenever it is required. And whatever. Oh, 4 minutes wasted. Very good job, Rajshekar. Okay, let's get started. We'll focus on basics of neural networks. We might not follow this number of days because we're going a little slower. So the number of days will be more than that. But I think even though I tried to see if we can fast track this and then make it quicker, which I did last time. Every time I do it, there is some issue with it. So I'm thinking I'll spend more time, go through each step in detail, um, so that this time it works out in different way. One thing is it'll take more time from switching to other jobs and all that stuff. It should be fine. Um, but it's okay. So to be frank, the job is not the objective, but to learn this concept is the objective, so that irrespective of the job, I should be able to work in this space is the primary objective, and secondary objective is to get into job, because jobs gives me an opportunity to work on use cases which we usually would not have in hand to understand and stuff. So considering that scenario, the opportunity to work in the space is great, so that is in alignment. So what I learn, what I work is on alignment, so it will be like double learning kind of stuff. It's just more interesting, right? So not sure it picks up voice from here, but okay, let's try it. Let's get started with neural networks. Okay, so here, do we have settings anywhere? Hello. Mm, I'm not sure whether it is picking up voice from here or not. Okay, getting started with the neural networks. So let's start from basics quickly. I have written an article in Medium as well on neural networks, which actually reflects on the same thought process. But quickly, I'll say what people understood is, I mean, I think the key underlying logic on how they came up with neural networks is, my understanding. Again, it might not be the right thing. Someone could correct me. There are two dimensions to it. One, definitely, when you get complex data, um, linear regression kind of a models, which actually draws kind of straight line and stuff, wouldn't fit in and give a proper generalized model. We definitely need a complex equations there, which indicate that they are not straight lines. Complex equations are multi-degree polynomial equations, which actually gives us some kind of a curves, which would actually fit into the data much more efficiently, so that they, and it could be multi-dimensional and all stuff, right? So one thing is that, so that is the most of the models are going to be complex linear equations, doing math calculations with respect to gradient descent and other optimizations and stuff is pretty difficult with huge amount of data and multiple parameters, and then fine tuning multiple parameters, deriving an equation, trying out multiple polynomial equations and stuff. It's very complex. Okay, that's one thing. Second thing, intelligence. When all our intention of designing all these models is to create some artificial intelligence using machines, correct? So intelligence for machines to learn things that human does and do them, I would say, with intelligence, but the the comparison factor for machine will be humans. So humans natural intelligence that is there, it should be simulated, or it should be adopted by machines is the objective in which we are going. Intelligence of human beings is in a way, intelligence of human beings is artificially being replicated. That is the reason it becomes AI, artificial intelligence. So now, why am I saying that is, that's the baseline. So people, I would always focus saying people should have a clear connect with that baseline, and then when you start building stacks on top of it, you're always connected to the grassroots on why you do it, and that will give you decision making skills that will make you uh, implement something with a complete understanding, not just because, yeah, neural networks, CNN, RNN, so I'll implement that. For a use case, beyond that, you should actually have a grassroots level link to why we do this to top model level implementation level detail on what why you do. So you think through all the levels before taking a decision. That's the important piece. Okay, now intelligence of is being replicated. Agree. Now, look at human intelligence. Or the term we used is previously natural intelligence. How does people's intelligence come from? Okay, so people's intelligence comes from primarily there are so human body, all the parts contribute towards person being intelligent to perform actions, to grab as to grab knowledge, to understand things and stuff, but primarily it is driven by brain. Okay, so in brain, if you look at the way the brain is nothing but it's lot of nerves which are I'm not sure. That's science, and I should not go there. But I'll say the brain constitutes of millions and trillions of neurons interconnected to each other, and every reaction that we make, every decision we make, every calculation we make, or every word I speak now is actually driven by those neurons being fired, which will actually tell me which is the right word to use. So, basing on when I learn English language, it actually kind of memorizes saying all the words and when to use which word, what does that word mean, is stored inside. Now, in this context, my thinking says these are the words I need to speak, then it retrieves that particular words that are there in my brain, and they actually I and give it out through my voice, saying, okay, this is the word you need to speak because your thinking goes like this. So the starting point is thinking, and it is mapping the thoughts are being mapped to words, um, to give it a to give to communicate, and the words are coming out. Uh, Ideally, it's the thoughts and the way you think are the primary contribution to intelligence. So, uh, so these neurons which are interconnected to each other, one thing is for sure, they observe that they are distributing their work. So the intelligent output that is coming in is being achieved by these neurons firing. So like, let's say brain has so many neurons, but what happens is, reaction or to a specific scenario is basing on the neurons, certain neurons being fired, certain neurons in our brain at certain space being fired together, and those will give certain output, and that gives me a reaction saying, okay, I need to rub my hands, I need to wave my hand to signal something. All of this is basing on different neurons that fire and tells my hand through its motor skills and stuff, saying you need to do this. Those are all controlled by brain basing on that those multiple neurons. So, but let's not get into the detail of what it really means. But let's stop firing. I could actually, because anyways the screen is sharing, I could go here and then pull up here, show you diagrams. So neurons are like this, and they would actually they would be like this. So whatever you see, this one is a very small part of like this, and they are in turn connected through these connections that they have. two other neurons and they get fired in neurons. Specialized task, correct. So this is something, I mean, not to relate, but in Iron Man movie, one of the movie scenes, they would actually show this on how the neurons would fire basing on your thinking, your pain center, blah 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 and stuff. That's a good watch actually. I mean, I know I don't have time, otherwise I would have pulled up that scene and then I would have shown you on how the brain shows up. But here they are capturing the neurons, maybe a small segment of the whole neurons on how they are firing and stuff. The brain scans show every synapse. Oh, it's full. 10 years ago. Now I'm deviating, but 11 minutes more. Yeah, this is how it would be. Yeah, so I think that is good enough. So they couldn't find the answer to the intrinsic question is, do we know on the pattern which they are getting fired? No, we don't. This video is 6 or 9 years ago. That's long back. Maybe now they have better detail. I don't know. Then patterns of brain activity 6 years ago, 11 years ago, 8 years ago. Neurons, how do they work 10 years ago? Interestingly, there is no studies published on 1 year ago. But this is protein data bank. This guy is 5 years ago, 6 years, 11 years, 10 years. So nobody is really working on brain, or they are not publishing their stuff, man. Seriously. Hmm. Interesting. Scientific image. This image computation useless. Also useless. Hey, seriously, there's no recent studies on brain, and that is published on YouTube. What happened? Okay, let's. There's something we should avoid. Let's come back to the original story. So, brain has neurons. Neurons fire in certain. A group of neurons fire in certain sequence to make intelligent decisions. When I say intelligent decisions, could be simple word that I speak. It could be a hand gesture that I want to make, or it could be some eye movement that I'm making. But every damn thing that we do is actually driven by brain by firing those neurons. And if those neurons are not fired and brain doesn't activate, then those actions can't be done. So we talk of people who has some kind of a brain injury who in turn can't use their eyes or use their voice, or they'll lose their motor skills. Not that these organs are impacted anyways. Only thing is these organs are being in turn connected to your nervous system by brain, and if your brain specific parts are impacted, those brain parts are in turn not giving proper signals to these parts. So those parts, even though they are there, like a power connection, right? Even though uh, you have a vacuum cleaner or something like that, you don't have the power connection working, it would not work, right? So it doesn't mean that the vacuum cleaner is not working. It is working, but it's not able to get the power. Similarly here, if the brain is not working, it is not receiving proper signals and stuff. So overall, that's the understanding of intelligence and how brain works and the neurons and stuff. So why it is very important for neural network is the concept of neurons on how they are linked up and they fire together to generate something. That was the underlying factor. And with looking at what this is the second factor for which they thought through that we need to bring in neural networks. I'm definitely sure that most probably this neural networks is more an experimental feature that they tried, and it worked out. It started performing well. Similar to current LLMs that are there and stuff. So even LLMs are experimental. If you dig deep into it, we don't have a underlying logic, specific logic, which actually says um, saying they built a model knowing that it's going to predict these words in a particular sequence. No, matter of fact, they don't even predict complete sentences. They predict words. The way I think the brain also works the same way. All it tries to predict is what, basing on my knowledge and basing on this context, what is the logical word that I need to use next so that I can actually convey my message. Again, if my basing on my English knowledge, my grammar understanding, or the overall linguistic understanding that I have learned or got exposed by different mediums. The sentence formation is driven by my brain, because um, that's what it knows. That's what I exposed that to. If I would have exposed it to more or specific details about language, um, my sentence formation or the words that I use now would have been different. Um, so I'm lost in thoughts, saying, okay, going back on neurons and stuff. So we that I mean, what I was simulating is that a large language models on how they predict the sentences that they need to respond on and stuff. That is being correlated with how the brain works with respect to the way we speak or way we communicate and stuff. But moving back on neural networks, so they tried to simulate the neural network's behavior to see how it would work, and then amazingly it worked pretty well. And um, so what happens in a neural network? Let's get to, so they take what you're seeing here in the brain is the neurons being so if you see here, the brain, the neuron, this is one neuron, this is another neuron, and those neurons are connected to each other and they exchange data, right? It has dendrites through which it connects to other one. It has axon and other connectors through which it connects to other neurons. Like this, there are multiple neurons that get connected to each other, um, and they make the processing. Similar to that, they what they did, they took this particular neurons being millions of neurons being connected to each other in order to process something, and then um, give you a response. Extracting that logic, what they came up with is similarly, this each neuron we put it here, and we said, okay, let's also connect multiple neurons to each other and then see how they'll behave. But the key thing is, what should this neuron do? um, Now if you, as we are comparing brain and here, matter of fact, we don't know what the brain does exactly. So we, basing on our knowledge, we have decided what this neuron should do, each individual neuron should do. Okay, so but still the journey is same. There is an input feature, set of input features called x1, x2, x3, whatever, and you need to derive the output as y. Or y could be classification as 0, 1, 2, 3, or y could be some continuous value as the price prediction of a house, like 200 million, 300 million, whatever. Not sorry, 200k, 300k is my meaning. I'm not talking about buying houses at 200 million, 300 million. I hope people don't spend so much money on their house. Okay, so now what should each neuron do? Okay, and I also said brain activity and a complex linear regression. These two, how I'll connect it here is, so there are multiple neurons that are connected here. So we'll get to the equations. It is difficult for me to type, man. That's complicated, but I'll. So we'll start off with one neuron. Okay. If you take one neuron, what they do in one neuron. Okay. I'll. So this is how one single neuron would work. This is nothing but linear regression, right? Linear regression's equation. I mean, they picked up a sample equation, but need not necessarily be that equation. Linear regression also can be multiple equations, correct? So a one neuron, the term they use on what happens on top of single neuron is um, y is equal to linear regression is one level, and they wrap it with an activation function. So this shows you more like x1, x2, x3, xn, w1, w2, w3 bias input. You do a sum of it, right? And then you send it through an activation function, g of x, and then you receive output. So this two combination, that is, this is linear regression, correct? And this is activation on top of it. So each neuron, it has two steps. One is the linear regression, which you already know, wixi sigma wixi plus b, and which is what is here, this wx plus b. And on top of it, we also use an activation function. Okay, activation function could be anything. It could be a sigmoid function, ReLU function. There are multiple functions. We'll go through all the list of activation functions, what are the formula and stuff, and then we'll also look at how do you pick a specific activation function based on the need kind of stuff. For example, we do this. This activation function is nothing new. We already did it. If you guys can think of it, when we studied logistic regression, what did we do? We did calculate linear regression, and linear regression, we call it Z. Z is equal to W ixi sigma wxi plus b, and after calculating Z, we put it into a sigmoid function, and for logistic regression, which will actually help us to try to keep the value in between 0 and 1, and basing on that value, we will take a call for classification, binary classification, correct? So 1 by 1 plus e power minus c is what we used as sigmoid function. The logic of sigmoid function is there is nothing logically. We know that there is something called sigmoid function which has values ranging from 0 to 1, and so irrespective of the continuous value, linear regression gives us continuous values, we know it. Objective of logistic regression is to get 0 1, so we put it into sigmoid function, which we mathematically know that it gives its range is 0.0 to 1 to any given values. So we are trying to fit in that particular linear regression output values into the sigmoid, because, and we are, so that we map them to our y values kind of stuff. So similarly here, activation functions are picked up. Matter of fact, one of the activation functions is also sigmoid. So sigmoid can be passed, and it activation functions helps in taking the output of the linear regression equation closer to the corresponding y. Okay. Now, that's what one neuron does. Okay. What happens when there are multiple neurons in a layer? So, okay, what we thought of doing is simulating brain. Brain has multiple neurons, and these neurons will pass values from one set of neurons to another set of neurons, correct? So observation is, it's not like input comes in, it is given to one neuron and then that is passed to another neuron and so on. That's not the way it is done. The way it is done is the input that is coming in, for example, the view that I see on the screen is taken by my eyes and it is passed on to the brain, and those are features like whatever I see, x1, x2, x3, x4, x5, or features. It could be multiple things like the depth of it, the colors of it. Everything is one feature. That's how you should look at it. And that features are given to my brain, and it is not given to one single neuron, right? At a point of time, the whole input is given to multiple neurons. Um, What do they do? We don't know. Okay, fine. I'm not saying that they neurons also run linear regressions and then they do activation functions and all that stuff. I don't know. So again, these linear regressions and activation functions and all something that we are imagining that a neuron could do, and I mean, the other way, that is something we know and we are trying to put it onto a neuron because we don't know what exactly neuron does. Great, nice. So now what they do, we're using multiple neurons. Okay, so we, instead of passing all these input values here to one, this is one neuron, instead of passing it to one neuron, we pass it to multiple neurons. So okay, if you go here, instead of, see, x1, x2, x3, x4, instead of, this is input layer. Okay, these are all features. Instead of those being passed to one neuron z and activation function f, right, giving it one, we give it to multiple neurons. Okay. This thing that it does is the same. Then why are we passing it to multiple neurons is, the difference would be wixi plus b and activation function g on top of it. X is same for all three of them. What will be varying is wi and bi. So we use three different wi bi. So it is like we don't know what is the right uh, notification. Sorry, I got a notification. So I was saying notification. We don't know what is the right model, that is wixi or g or wixi plus b to be used. So what we are doing is we are going with multiple neurons. Actually, frankly, that's the logic. So if you, for example, if you know one wixi plus b linear regression, which actually clearly gives you results, either continuous values or a binary classification. You draw a line and it clearly shows these are all um, these are all foods which has sugar and these are all foods which has nuts. So sugar, you draw a line and you, why do you want to use neural networks? You don't need to. One single neuron or one single linear regression, you're done. You can do it. Not necessarily you need multiple neurons. But we couldn't arrive at a conclusion, as I said previously, about complex linear regression linear equations. You can't do it with one single line or so, or one simple equation, or you don't know what is that single equation that could do it. So what they're doing, we will get to the math of it. They're using multiple neurons. So what happens, all x's that are there, input features x1, x2, x3, they're giving it to three models at the same time, three neurons at the same time. So three neurons have three z's calculated with different w's. Let's say the whole matrix of wi is, this is w1, w2, w3. There are three weights and b is bias, right? So three bias, b1, b2, b3. So w1, w2, w3, w1s, w2s and w3s, and b1, b2, b3s, three different models are executed in parallel. That's the whole thing. And what we are doing is we are going for multi-layer. That means x is given to these three people. These three people give me now three outputs, correct? If I give to three models, they'll give me three outputs. Now, we don't know which output is correct, right? What we are doing is, when we say multi-layer and we don't know what is the output, which output is correct, we are giving these three outputs to few more models, and few more models, basing on these outputs, they'll try to predict what is the output value. So let's say they call this as activation function. So the output of them, let me call them as a. So it will be a1, a2, a3. x1, x2, x3, giving it to three models, it will become a1, a2, a3. Now, so instead of one person coming and solving a problem, three people have solved it. But the challenge is there is no answer for it, right? There is answer for it, but these three answers are not same, could not be same as y, and we need more experts to process it, right? For us, expert is whatever model that you have, same linear regression with some kind of a activation function on top of it. So what they thought of, as if again simulating the thought process, if you observe, as if in brain, the way the neurons are, multiple neurons are being fired with for a given input, and they are in turn passing those to different neurons. Similar logic, what these people are doing is they are giving it to multiple models, processing it, and these multiple models output in turn are being passed to another model. So that's how, if you look at the neurons, see, this guy is showing only two. So, but if you look at it, what happened? This particular dendrites that are there, these all, they are not like this is one to one neuron. Okay, this, if you see this neuron that is there, it has this. Let's talk of it like wires, right? So these wires in turn are connected to multiple neurons. So what happens once this gets fired? This fired output will actually go to this one, could go to this one through this, right? So the output of it is being passed to multiple neurons, and those could in turn give to multiple neurons. So we don't know how many neurons should be there, how many neurons will process, what exactly they do to finalize the output and stuff. But we see that there are multiple neurons being used. So the thought process came. Uh, the thought process came that same similar concept should be used by us as well, like this. So same, whatever is there, like multiple neurons connected to multiple neurons, they bought in, they put multiple neurons here, and then the output is what we are looking at to classify as y. So x1's given to multiple models, which give us a1, a2, a3, a4. A1, a2, a3, 4 again are given to multiple models. So again, wi a1, sigma wi a1 plus b1, here it's b1, but I'm just saying b of this layer. So let's say b1 one layer, b1 2 second layer. So b1 2, b2 2, and b3 2. So that's of this layer, and again we calculate on top of this, we calculate here activations, and those activations in turn are given to a final um, function, and that final function could give, it depends, like let's say if you have a classification problem where you need to output three classes, then this could be your final layer. But or let's say if you want to output a continuous value, which is, or you do a binary classification where you need one single classification, you go with one node. So this is the outer layer, this is input layer, this is output layer, these are called hidden layers in between. So this output layer, again same function, you take this is a1, a2, a3, a4, let's say a5, a6, a7. Then a5, a6, a7 again are given here, and it has w13 plus and b13, then w13 a a5, a6, a7 plus b13. This is what is calculated, and activation function applied on top of it as per the output needs. Again, if it's continuous value, continuous value. If it is um, if it's a binary classification, blah blah blah, we pick corresponding activation function, we go output. So that's how the neural networks would work. I hope this is clear. We crossed the time, we reached a lot of things, but I think the fundamental concept of neural networks goes like this. This is definitely very interesting session. It would have taken 45 minutes, but it is very nice and a very good understanding of neural networks, I guess. Okay, then we'll get to more detail. We'll try to do some math on how these neural networks pass on the details and how they have work and stuff with equations and stuff. I'm wondering how I'll show you those inputs here. Maybe I'll just ask ChatGPT or something like that to do the calculations with respect to math equations so that we can see on the screen how it goes kind of stuff. So let's try it out tomorrow. Okay, that's all for today. See you guys tomorrow.